Hello everyone. Um, how are you? Yes, I hope you are fine. So in the last video, what we have studied units and dimensions, right? So what are units? What are dimensions? We have also seen how to find the dimensions of some physical quantities, right? After that, what we have studied, we have done dimensions analysis as well, right? After that, we have studied significant figures. So these topics we have covered. Okay. So now we are going to do questions on all these topics, units and dimensions plus significant figures. The questions which came in the previous year examinations of NEET. Okay. So the first question is the physical quantity that has the same dimensional formula as pressure. So we have to find the physical quantity which has the same dimensional formula as pressure. Okay. So firstly, we will write like coefficient of viscosity. We have force, momentum, and Young's modulus of elasticity. So firstly, we will write what is the formula of pressure. Pressure is force upon area. So we can write the dimensions of pressure from here. What are the dimensions of force? ml t minus 2 and area is L square, right? So what will be the dimensions of pressure? M L1 minus 2 is minus 1 and T minus 2. This is the formula of pressure. Now we can check the quantities one by one. For coefficient of viscosity, eta, what we can write is, it is M L minus 1 T minus 1. Correct? Second physical quantity is force. What is the dimension formula of force? It is M L T minus 2. Right? In the C part, what we have, it is momentum. Okay, so we denote by small p. Small p is m into v, mass into velocity. So mass, and what is the dimension formula of velocity? Lt minus 1. And fourth is Young's modulus of elasticity. It is denoted by capital Y, right? Then Young's modulus of elasticity means it is stress upon strain. Okay, so its formula is ml minus 1 t minus 2. This is the formula of Young's modulus of elasticity. So which option is matching with the pressure? ml minus 1 t minus 1? No. mlt minus 2? No. mlt minus 1? No. ml minus 1 t minus 2? This is matching, means this is the answer. So Young's modulus of elasticity is the answer of this question, as this option is matching, na? Right? Let us move to the next question. This is very easy because this topic is not so much difficult to understand, right? If we know how to find the dimensions of some quantities, we can write the dimensions of other quantities. So in this way we can solve. Okay. So the next is, if force, acceleration and time are chosen as the fundamental physical quantities, find the dimensions of energy. Okay, like ml and t are fundamental. So here these three quantities are given as fundamental. So we can write energy as E. How we can write energy as E? So E is dependent on force, F raised to power A we can write, and acceleration A raised to power B we can write, and time T raised to power C we can write. इसका मतलब है कि जो एनर्जी है वो किस किस पे डिपेंड कर रही है, फोर्स पे डिपेंड कर रही है, एक्सेलरेशन पे डिपेंड कर रही है और टाइम पे डिपेंड कर रही है. वी कैन राइट थ्री क्वांटिटीज. ठीक है. इफ वी रिमूव द प्रोपोर्शनैलिटी साइन, so we can write dimensions like this: E will be equal to k times dimensions of f raised to power a, dimensions of a raised to power b, and dimensions of t raised to power c. Right? So what is the dimension formula of energy? m1 l2 t minus 2. Right? What is the dimension formula of f? m l t minus 2 raised to power a. This is acceleration. Acceleration is lt minus 2 raised to power b. And this is time, t raised to power c. Okay, so left hand will be same. m1 l2 t minus 2. Right? What we can write? We can change m raised to power a, l raised to power a, and t raised to power minus 2a. This will be l raised to power b, t raised to power minus 2b, and t raised to power c. Right? Again, it will be m1 l2 t minus 2, and we can combine all the powers of ml and t. M raised to power e here. What is l? L is a plus b. Next is t. T is minus 2a minus 2b plus c. Correct? Now we can compare the powers on both sides. M a is equal to 1 from here. Right? Next is a plus b is equal to 2. So substitute 1 here. 1 plus b is equal to 2. B will be 1 from here. Next is minus 2a minus 2b plus c is equal to minus 2. Right? So substitute the values of a and b here. Minus 2 into 1 minus 2 into 1 plus c is equal to minus 2. This is minus 2 plus c is equal to minus 2. Minus 4 plus c is equal to minus 2. C will be minus 2 plus 4. So what will be the C? C is 2 here. So we got the values of A, B and C, means A is 1, B is 1, C is 2. Then you can write from here that E is equal to F raised to power 1, A raised to power 1 and T raised to power 2. This will be the answer. Right? So this is very simple again. F A T raised to power 2. So which is the answer? This is the answer, C. F A T raised to power 2. Okay. Correct. Let us move to the next question. Next question is, plane angle and solid angle have units but no dimensions, dimensions but no units, no units and no dimensions, both units and dimensions. So in this question, what is asked? It is being asked that you have to find units and dimensions of plane angle as well as solid angle. Okay, so you can find both. Firstly, we will find about plane angle, that how plane angle is there. What is the formula of plane angle? It is arc upon radius. As we all know that theta is arc upon radius. Okay, arc will be in the length L and radius is also in the length L if we have to find the dimensions of theta. So L and L, it will be M0, L0, T0. Okay. And what is the unit of theta, plane angle? It is radians. Okay. Now we have to find for solid angle. Correct. Now for solid angle, it is area upon radius square. This is the formula of solid angle. So area is L square and radius is square. That means L square. Okay. So it will be M0, L0, T0 again. And what are the units of solid angle? It is steradian. So this steradians is the unit of solid angle. Okay. So from here what we are seeing, that plane angle has no units, M0, L0, T0, but it is having a unit, that is radians, but no dimensions. Okay. So solid angle, it is also having units steradian, but it is not having any dimensions. So from here what we can say, that plane angle and solid angle have units, but it is not having dimensions. So which option is matching from here? A option. A option will be the correct, because it is saying that plane angle and solid angle have units but no dimensions, because dimensions are not there. Okay. Let us move to the next question. The next question is, the E and G respectively denote energy and gravitational constant. Then E divided by G has the dimensions of. Okay, means we have to find the E by G ratio with respect to dimensions. Okay, so firstly we will know what is the dimension of E and what is the dimension of G. So energy, it is E. What is the dimension formula of energy E? As we all know, ml2 T minus 2. Right, this is the dimension formula of energy. Now next we have is gravitational constant. It is G. So how you will find the dimension formula of G? We know the formula of gravitational force, right? What is it? F is equal to G m1 m2 divided by r square. This is the formula, right? So what is G from here? It will be F into r square divided by m1 m2, right? Now you have to find the dimensions formula of G. How will you write? It will be dimensional formula of F, dimension formula of r square, dimension formula of m1 and dimensions of m2. What is the dimension of force? It is ml t minus 2, right? L square, and what are these? It is m into m. So what will be the dimensions formula of G from here? It will be m minus 1, L 2 plus 1 is 3, T minus 2. This is the dimension formula of G. Now you have to find the dimensions of E by G. This we have to find. So we will substitute E is m L2 T minus 2. And what is G? M minus 1 L3 T minus 2. Right? So M1 plus 1 will be M2. L2 minus 3 is L minus 1. T minus 2 plus 2. T will be 0. So this is the dimensions of E ratio G. So which option is matching? You can check. M2L minus 1 T0. M2L minus 1 T0. It is not there. M2L minus 1 T0. See, this option is matching. You can check others also. M1L minus 1 T minus 1. This is not there. Next is M1L0 T0. This is also not there. So the correct option is B. Right? This is also again very simple question. Let us move to the next question. Next question is dimensions of stress are. You have to find the dimensions of stress. So stress is a kind of pressure again. This is very, very simple question. So what is the formula of stress? Stress is force upon area, right? So what you have to find? The dimensions formula of stress. Dimensions formula of stress will be force upon area. What is the formula of force? It is ml t minus 2, right? And area is L square. This is the formula, mlt minus 2 and L square, right? So how you can write stress? It is m1, L1 minus 2 is minus 1 and T minus 2. This is the formula of stress here, ml minus 1, T minus 2. So check which option is matching, ml minus 1, T minus 2. This is ml2, T minus 2. This is not there. ml0, T minus 2. It will also not be there. ml minus 1, T minus. See, this is the correct answer. And this is again wrong. It is L1, but we have L minus 1. Correct? Yes. So this is also very, very simple question. So we have done many questions on dimensions and analysis, right? Any doubt in these questions? So all our questions are clear. If you have any doubts in any of the questions, you can drop in the comment box. Okay? Yes. So we have done these questions. Now let us move to the significant figures question. These all questions are based on the units and dimensions topic as we have covered. Okay, let us move to the questions of significant figures. Significant figures topic is not of much weightage, but sometimes question comes, so you have to solve. Okay, so as I have told you in the class also that significant figures topic is very important because you have to just keep in mind how to round off the values. Okay, so what is the correct significant digits it is saying? So see this question. It is the area of a rectangular field in meter square of length 55.3 meter and breadth 25 meter. After rounding off, the value for correct significant digits is. Right. What we have to do in the question, we have to find the area of the rectangle. Firstly, length is given to us. Length of rectangle. Okay. So how will you write length of rectangle? Length of rectangle is L. Correct? L is 55.3 meter. Next is breadth of rectangle. What you can write in breadth of rectangle, it is B. It is 25 meter, right? What you have to calculate? You have to calculate area of the rectangle. Area of rectangle is A. A is L into B. As we all know, the area of the rectangle is length into breadth. So length is 55.3 and breadth is 25. So multiplying 55.3 and 25, what we are getting? We are getting it as 1382.5. This will be in the meter square. Meter into meter will be meter square. So this is the value of area. Okay. So from here we can round off the values. We can round off because we have multiplied them. Okay. So in multiplication, what we see? Least number of significant figures. So here there are how many significant figures? Three significant figures. And here it is two significant figures. So we have to round off the result according to the two significant figures because least number of significant digits are taken into account. So what will be the value of area here? Okay. So what will be the area? Firstly, we can shift the point, right? We can shift the point here after two digits. It will be 13.825 into 10 raised to power 2 meter square, right? Now we have to write in terms of two significant figures. Okay. So this will be area is equal to, it can be 13.8. Okay. So it will be 14 into 10 raised to power 2 meter square. Because 8 is greater than 5, so we have added 1 into the previous number. So it will be added. So this will be the area of the rectangle, right? So A is equal to 14 into 10 raised to power 2 meter square. Because these are not counted in significant figures. From here we can see it is having two significant figures. So what is the answer? 14 into 10 raised to power 2 in meter square. Correct? So this is the significant figures. In the class, last video we have studied about this, that how to find the significant figures in addition and subtraction, plus multiplication and division as well. Okay. So this is also one more question. Taking into account of the significant figures, what is the value of 9.99 meter minus 0.0099 meter? So you have to subtract in this. It is 9.99, okay, meter, and we have to subtract from this 0.0099 meter. Okay, we have to subtract. For this we can substitute here 0 0. It will be 10 minus 9 is 1. It will be 9 here. 9 minus 9 is 0. 8 will be left. 8 minus 0 is 8. 9 minus 0 is 9. And 9 minus 0 is 9. Correct? So if we will substitute 9 minus 99 minus 0.0099. So we are subtracting this number. So what will be the left? 9.9801 meter. This is the left. Okay. So this value is left after subtracting. Now we have to see in addition and subtraction, what we see? Least number of decimal places. Whichever digit is having least number of decimal places, we have to round off the answer according to the least number of decimal places. So here the decimal places are how much? 2. And here the decimal places are how much? 4. So we have to find the least number. So answer should be according to the 2 decimal places from here. So we have to write according to 2 decimal places. So what will be the answer? It will be 9.98. meter. This will be the answer. So this is having 2 decimal places. Correct? So 9.98 meter will be the correct answer. So you can see here 9.98. Answer A will be the correct. Okay. So they are very simple. This topic is very, very, very simple. So if you have any of the comments, you can drop me in the comment box. Okay. Okay. In the next video, we will study about new topic. Yes. Okay. Thank you so much.